This is my notebook for the long context Kaggle Gemini competition. Here I'm using single nucleotide polymorphism data, which is just SNP, and then related research for those different SNPs. Now, the overarching question was what happens if we can feed mass amounts of genetic information in academic literature about a specific gene to an LLM. That's kind of what sparked this project. I'm going to gloss over most of this notebook because I don't have time to cover everything. But as we know, genomic information is quite lengthy, and with most LLMs, we're not going to be able to fit really anything into the context window, as each SNP response can be in the tens of thousands of tokens, and each associated piece of literature can be in the hundreds of thousands of tokens. But with a 2 million large context window, we can surpass that. We can pass in tons of SNP data, tons of academic literature to produce really cool responses. The 4 different areas this information can be used from, which is by no means exhaustive: generating novel questions, insights that can be asked about the data, answering specific questions about the data, summarizing the important information about the SNPs related to a gene, and then generating a novel study and research design based on the data. I'm going to gloss over most everything, minus the actual Gemini API stuff. But essentially what this notebook is doing, it's retrieving a bunch of SNP data from the NCBI DB SNP database, and then it gets the research articles right here, citation papers that are associated with each SNP, downloads them here, and then I initially was going to extract the text from the PDF, but given the number of PDFs, I decided to use a really convenient file API from Google, which the file API allows someone to just upload videos, images, documents to the API, and then use them later as context for Gemini, which is pretty cool. So here's where that's happening per final data with the file API. So for each PDF, we're uploading that to the file API so we can use it later, and we're returning that final SNP data, which has all the SNP data here, and then PDF data, which is just a list of the uploaded files to the file API. And then we're uploading the gene expression data, which is just where it's expressed in each tissue. And then here we're preparing the final data that's going to be sent to the API. So we just have an empty list. We're adding all the SNP data and each of the uploaded files. Then here we have the different prompts. I'm not going to go into details, as you can look at this on your own, but we have the 4 different kinds of prompts: innovative question prompt, the answer prompt, the research design prompt, and the summary prompt. And then finally, the system instructions that are the base context for all calls. And then all the different questions we ask the LLM. And then here's the other really convenient part of the Gemini API, context caching, which is amazing to use. So given we have millions of tokens, we have greater than 1 million tokens going into the model, we can cache most of those. Here you can see we're passing that contents variable to this method. And now for each successive LLM call, it can use those cache tokens and really reduce the cost for each call. And given we're in the millions of tokens, that cost reduction can be significant over time. And then we can pass the system instructions, how long the cache is going to live, display name, etc., etc. And then finally, we just have the different kinds of prompts and actually passing those to the model. I can't really get into detail due to time, but the best one, so here's to generate novel questions. And then the summarize information is the best one, as a researcher can get up to speed really quickly on a particular gene and all related pathogenic SNPs to that gene. And then finally, the research design prompt, where it can output full-on study designs, which could take a while for a researcher to actually generate. So I hope you like this video and this use case for the large context window for Gemini API. Thanks for watching.